This lecture describes the CodeWorld's version 2 or V2 project, which is a significant enhancement to the CodeWorld's V1 that uses many of the ideas presented in the preceding lectures. So let's start off, first of all, with a demo of what CodeWorld's V2 actually does. This demo constitutes an important part of the spec, really, since user interface is best described by a video rather than text. So as you can see here, CodeWorld's V2 provides a much more sophisticated world layout than V1, with a variety of different materials and animals, and the ability to assemble complex patterns from them. So the clunky text display is replaced by this graphical window, which shows icons in each occupied brick of the grid. There are 7 brick types, and these are tree, like this guy here, stone, ore, a little reddish one, water, bluish one, cow, and there are cows here. You zoom in a little so you can see them. There's a nice little cow. All right. And then there's also horse and sloth. Now, some of these you'll recognize from version 1 and others are new. And there are examples, as I've just showed you, of cow, water, stone, ore, and tree. And there's also the horse and the sloth, but they are shown as small colored dots, sort of a sad-looking horse here. And part of the challenge in version 2 is to code decent icons for those last two, a chance to exercise your artistic skill. Now, note also that the UI has some clicking features. We can click to different areas in the world. The world generally might extend beyond the window boundaries, depending on its dimensions. We can also zoom in with a control click like this. I'm holding control down while I click the mouse to get a closer look at part of the world, and then, like I said, kind of scroll around by clicking. And then we can zoom back out with a control right click to see the larger view. Now, you don't have to code the graphical window. That is supplied. Feel free to look at its code if you like, but it's not required for the project. You just use it. Now, that's the new user interface in a nutshell. Let's look now at the code in more detail. First of all, CodeWorld's V2 reads its world layout from a rather more complex file than did CodeWorld's V1. And here's an example for the world layout shown. You can see it starts with a series of parentheses enclosed pattern declarations. Each of these has a name like stand or forest. And after the name are one or more pattern elements with the element name and then an XY location. So we can see in our example that a stand, that's as in a stand of trees, it comprises 4 trees at various XY locations. Now, importantly, a pattern declaration may also use prior pattern declarations as elements. Forest, for instance, comprises several stands at various XY locations. The XY location in this case is an offset to add to all the elements of the subpattern. So, for instance, stand of 2, 3 would imply a pattern of trees, tree 2, 3, adding 2 and 3 to those, and then tree 3, 5, and tree 5, 5, 6, and so forth. So anytime a pattern is used as a subpattern, it's offset by the X and Y given in the subpattern declaration there. Now, the fact that pattern declarations can include any mixture of elements and other patterns means that we can stack up arbitrarily deep patterns. These trees over here, for instance, are actually several different stands together as a forest, and then several different forests to make a larger collection of trees. And same thing is going on with the water here. Look further down in the file, there's a pond, and it's got water parts, and you can make a larger set of water by grouping a bunch of ponds together. Now, a design pattern should suggest itself at this point, and this is question 1. What design pattern is appropriate for this hierarchical arrangement? Turning from a pause there, a composite. Right? V2 definitely uses a composite design pattern. Now, pattern declarations in the input file here don't actually add anything to the world layout. They just set up patterns that can be used to do so. So the actual content of the world comes after the pattern declaration, and it comprises a series of one or more simple declarations, each comprising either a built-in type or a pattern followed by an XY offset. So in the sample file, for instance, our world comprises 3 ponds at various offsets, and then 3 forests, and then 2 rock fields, a mine, 3 cows, 4 cows, I'm sorry, 2 horses, 3 horses, and a tree. Right? Now, question 2. Looking at the image here, consider the 2 stone squares that are just below and to the lower right of these 3 reddish ore squares. So these 2 guys here. Right? Identify which lines, exactly which lines in the input file caused those squares to be stone. Track the entire hierarchy of patterns that's involved. Okay, and the answer is, well, they're part actually of the mine pattern up here that in turn includes a rock field pattern, which has a boulder, big square thing, and then 2 stones at 3, 2, and 1, 3. And these 2 stone lines in the rock field pattern are causing the 2 stone squares from left to right here. Now, before we go further, please spend a bit of time reviewing the lecture and code for CodeWorld's version 1. You'll need those fresh in mind for this discussion, and in particular review the vector and margin vector classes, the displayable and display interfaces, and the animal class and its subclasses. It doesn't have to be line by line, by the way, but enough to be familiar with those so we can talk about them. Now, once you've done that review, let's take a look at the CodeWorld's v2 code, and in particular looking at changes from CodeWorld's version 1. And we'll start with ones that don't involve new code that you must write. More complex ones in the following lecture segment. So first of all here, vectors. We have simplified the vector class by merging turn vector and margin vector into the vector base class and dropping those subclasses. The vector subclasses were a good intro to object orientation and to inheritance, but it's easier in practice to have just one vector class. Also, vector has converted from double values to ints. Now, integers are less precise, but they don't exhibit rounding errors. And as the CodeWorld's simulation gets more complex, rounding errors will make it harder to automatically compare your output against a model, since a trivial difference in rounding can cascade to cause very different behaviors as simulated time progresses. Now, another item, one I can't show you because it's simply not there anymore, steppable has been dropped for now. It'll come back in version 3, but CodeWorld's version 2 concentrates on setting up interesting initial worlds, not on simulating movement and changes to the worlds. So, no steppable. Rectangle. This one's new, and rectangles will show up fairly often in later versions of CodeWorlds, for instance, to describe the boundaries around a pattern like a forest or a stand. Now, Java has a built-in rectangle class, but it's not a good fit for our needs, so we'll have our own, and that is this class here. Question 3, I'd like you please to read the rectangle class carefully and then explain why we are adding 2 times margin on these 2 lines. Why does it make sense to do that instead of just adding margin? Returning from a pause there, the top and left values are reduced by margin in order to fatten the rectangle in that direction to the left and above. To also expand it on the right and on the bottom, then width and height first need to add margin to compensate for the reduction of top and left, just to hold even, and then must also add another margin's worth to expand the rectangle on the bottom and on the right. Okay, that wraps it up for the minor changes that don't involve work on your part. In the next segment, we'll look at the bigger changes to code worlds involving code that you do have to write for this project.